Everybody, I'm really excited to be here with you. I'm a huge nerd, and this is totally the conference for me. I've been using R for over 10 years and been developing packages in R for that time. Not necessarily great packages, but packages nonetheless. The nerdiness in me, I think, is most apparent in how I choose to tattoo my body. I have binary code on my arm, and then if you go a little further, those are hexes for, hex package stickers and stuff like that. Got a tattoo actually with Kelly. She's got a really cool one as well. She'll be speaking later, she can show it off. We also have data table swag, so if you're interested in getting any of these, so there's a pin and 2 sticker types. It's up here. Feel free to do that during my talk. We're here in part because of a grant that we got to help support data table, so gotta pay the bills. So here you go. All right, to start, I want to test your emoji game. Anyone know what that is? What's it saying? Titanic, boom. You guys are quick, like my kids. They can do it this fast. This one? Moon landing, yeah. This one. Van Gogh. I love the ear part of that one for some reason. That's the best. Okay, so those are not too difficult. Let's go a little bit more difficult than the quiz game. Anyone know what this is, the language? This is Fortran. Is that something you've written? How'd you know that so quick?
It's the language of nuclear engineering.
There you go. I love that. So Fortran, nuclear engineering, now you know. What about this one?
Lisp.
Yeah, lots of people knew Lisp. Love the comments. It's just the semicolon, it's amazing. And then this one, basic. Yeah. You guys are great. I knew that this would be the conference where people would just rattle this off. So what does this all have to do with anything with my talk today? Well, first is humans have this really unique, potentially, but definitely powerful ability to take symbols, language, whether that's spoken or written, and turn it into meaning. And we often turn it into things that are very productive. We may actually be the only species that can create something that doesn't really exist. So for example, money, that's not real, but we all go along with it. Calendar time, at least currently we do. Calendar time, we have, that's not real. Like we just make stuff up, and every once in a while we're like, oh, we gotta add an extra day. And then, like, was it every 100-something years, or every so often we have to backtrack a little bit, and so it's all made up, is all I'm saying. But we have this innate ability to make those real and then work within those systems. Now, language is a really kind of special aspect of something that we make up. It's really just noises and symbols on a page, but we create it into something that has really deep meaning to us. But the thing is that it also influences us back. And that's really what I want to talk about mostly today. But there's some really fun examples of some research that shows how language ends up impacting us. One is based on color. So with color, we have words that describe color boundaries. So we have blue, red, green. And the languages that have more color boundaries, they tend to have their brain lights up at more regions of the color spectrum because their brains are starting to see more boundaries between colors. The languages that have fewer color terms often have fewer boundaries that they perceive in the kind of color wheel. Another one is about direction. There's some languages, especially some native ones, that use absolute directions and not left or right, which are relative to us. And those individuals tend to have better spatial awareness than individuals that have languages that are relative directions. So individuals in those that speak those languages might know exactly where north is right now, and I have literally no idea. You could tell me anything and I'd believe it right now. Another one is how languages perceive time. There's kind of horizontal time where you picture time starting here and going this direction or vice versa. But you also can picture it as going up and down. So time is vertical. And then the last example is in languages with gender connotations. Those end up impacting how things are perceived. My favorite example of this is and I don't speak fluent German, but the word for bridge has a feminine connotation. So it is often written with things like beautiful or elegant, while Spanish, it's more of a masculine, and so it tends to have more things like sturdy and strong connotated with it. We're talking about the exact same thing, it's just a bridge, but the language that we speak influences a little bit of how we're perceiving that. So what does this have to do with us in R? Well, syntax has a handful of spectra. And we tend to be somewhere along that spectrum in a couple of these areas. There's a few that I want to go over. The first one is explicit versus implicit. Explicit makes the sequence of operations clear and visible, while implicit focuses on what you want to achieve rather than how to achieve it. It's often at a higher level of abstraction, so things are a little bit more hidden, but it's often quicker. I'm going to come back to those. With symbolic and verbose, symbolic is often really concise and expert-friendly, and it leverages domain conventions so that if you know the area, symbolic can be very quick to read and to write, where verbose provides more descriptive information, which can actually be self-documenting when done well in code. Come back to those two. And then the last spectrum I want to talk about is opinionated versus unopinionated. This one feels very loaded, a loaded term, but really it's just talking about whether it's trying to guide you in a specific direction versus not guiding you in a specific direction. So in order to really kind of talk about these, I want to bring up 4 really powerful tools. Ones that are really commonly used in the R world. One's kind of new to the game, but I think it's an important one to include. First is base R. I'm going to assume that everyone here is fairly familiar with that. That's pickleball, by the way. Data table, dplyr, and polars. They all have a different syntax to them. They have different ways of going about achieving these goals, but the goals are very similar. They want to achieve data wrangling and getting your data ready for analysis. Because I think I can assume here that you're familiar with base R, I'm going to skip that one. It is really great. Data table has this very distinct syntax. It's the IJ by syntax. It's all directed by the square brackets. So you have your data table name, which here I'm calling DT. And then when we want to do stuff to rows, we do that in the I spot. When we want to do stuff to columns, we do it in the J. And then when we want to do grouped operations, we use the by statement. And there's more that you can do as well. Now, dplyr is built on pipelines, and probably the majority of us are very familiar with these. Takes your data, do stuff, and do more stuff using either pipe, depending on your preference. It's built on a series of verbs which really mimic how we speak in real life. And I will note with dplyr particularly, it's more of a language than an engine at this point. I know it initially started as an engine, but now with dbplyr, dtplyr, duckplyr, all of those flavors, it's more of a language than the actual engine. You can actually rely on all sorts of backends to do the heavy lifting while still using this pipeline of verbs. And then polars, it's the newest of these packages if you are not as familiar. If you're in Python, you're probably seeing it more. But it's designed to mimic the polars Python library. So you're gonna see a very specific kind of flow with the $ in the R world rather than the dot for Python. But the idea is the same. It's every step you're going to have some methods that you can then apply to the data that you're bringing to it. It comes with a large list of functions that work internally in polars, like there's sum and mean and really, really common aggregation functions. There's quite a few. And it provides methods for each step, so it really guides you with the options that are available in each step. And it recommends lazy evaluation, which kind of short story for something that's fairly complex. It wants to wait to evaluate what you're giving it until it knows everything that you want to do. And like other backends that dplyr uses, polars will try to find the best way of accomplishing the goal that you give it. So a few examples just to kind of see it in practice. We're just using the mtcars, really common data set in R. This is how you would filter for base R. Data table looks like this. dplyr like this. And as you'll see, I'm going to go back and forth between the pipes. I can't stop myself. And then polars looks like this. So certainly some overlap between the four of them. You see MPG and the caret and 20. But the way that you get there differs, and there's different levels of guidance. Another example is summarizing, and I think to have these credit, I now type in English, the kind of formal with the S instead of the Z. I can't make myself do it. I kept doing it here, so I crossed it out. So this one way, there's many in R that you can aggregate. This is one way to get summarizing by group. Here we're getting the mean of MPG by cylinder. Data table, it looks like this. dplyr, very common workflow here. The group by and then summarize. And then polars, which you actually can design to look a little bit kind of like that dplyr code. This is how you could get that same result. So let's summarize this. This is not going to be real quantitative. It's more of a qualitative approach of what do these languages offer. So base R, it is famously unopinionated. That means there's a million ways you can do everything. You can approach stuff from almost any angle. And there's a range of implicit and explicit and symbolic and verbose depending on the functions you use. Because it's so unopinionated, there's lots of paths you can go down. Data table is a little bit more opinionated. It's telling you, hey, work within these square brackets. These are the places to do things. And it's expecting a pretty similar workflow when you're working within those square brackets. It's mostly implicit and symbolic. You don't have to name arguments all that often, and there's a lot of symbols. The square brackets carry a lot of weight in data table, along with a couple other operators. Now, dplyr is a little more opinionated as well. It guides you a little bit more as it's trying to help you go down a few paths that all kind of speak together. So the group by flow is very, very common, and it's one that it naturally guides you along. And it is a blend of explicit and implicit. It's explicit where the functions really name what it wants you to do. So you use select when you want to select columns. But there are some things that are implicit. Some of these functions still use the ellipses, and so you have to understand that, oh, in select, it wants column names here. And then it is more verbose, certainly more than data table and some of base R. And then polars, which may be the most opinionated of the four, because it really is guiding you along the whole way, giving you methods that work along every step. And it is more explicit, and it's quite verbose. I think it's something that people start to notice immediately, regardless of whether you're coming from dplyr or data table or base R, you start noticing how much you have to write out in polars. So one of the things I want to really hit home, though, is this quote: a modification increasing usability in one dimension typically reduces it in another. That is to say, there is no perfect syntax. I wish there was, and we would probably find it in this community, honestly, but there isn't, no matter how strongly you feel about whatever tool you're using. There's just not a perfect one. Now, they each present priorities. With data table and the way that the syntax is designed there, it's really designed to be concise and quick, but it's more built for experts, individuals that understand R and have used R long enough. Data table can feel like second nature. But for beginners, we've seen that it can sometimes be challenging, and being able to read something like the dplyr pipeline can feel a lot more natural sometimes. So depending on your priorities and needs, different options really start to take a priority. But the point is that there's not a perfect solution to everyone's needs. And the fact that we have these options is actually really neat in the R universe. We have a lot that we get to work with, and we get to really take what our priorities are and use that, and it makes us more efficient and better analysts. So thank you. I appreciate your time and attention. This is how to find me on socials, especially on Blue Sky and GitHub.